So we talked about calculating general terms of binomial expansion and how we can use these to do various tasks. What I'm going to do here is I'm going to give you just two questions looking at this and looking at working with general terms of binomial expansion. I'll wait to pause the video, have a crack at them, come back, check your answers. So here you go. First one, I just want you to find the coefficient of the x to the 5 term in the expansion of x minus 1 over x all to the power of 7. And the second one is I want you to find the term independent of y in the expansion of y take away 3 over y to the power of 6. So pause the video, have a crack at them, come back and check. So first one, find the coefficient of x to the 5 in the expansion of this. Now the first thing we have to do is figure out what our general expansion and our general term for this is going to look like. So this is going to stick with the same format for the binomial coefficient, nr, and it's then going to be times our first term, x to the n minus r, times what would be our y term. Well, in this case, that's that negative 1 over x. So it's then going to be times negative 1 over x to the power of r. Now, in this case, we know that n is equal to 7. So what we can then say is, fine, that's then going to be given by 7r, and put the 7 in for the n in this one as well. X to the power of 7 minus r times this. Now, this kind of one here, if you've ever got a fraction where you've got the variable on the bottom of the fraction, bring it up and make it a negative power. So that would then be negative x to the negative 1 to the power of r. Because what that does is that just makes playing about with this a heck of a lot easier. So I then get 7r x to the 7 minus r times, now one thing as well I'm going to tell you is your negative x to the negative 1, I want to split that and do negative 1 to the r times x to the negative r. I want to expand that whole thing out there. So what I'm going to do is expand it in this fashion such that I get negative 1 to the power of r times x to the negative r. Now the reason being is every odd number of r, I'm going to have a negative term. Every even number of r, I'm going to get a positive term. So we need to take that into account. So our negative 1 has to vary with r. You can't just include it with the x because it won't then change with every single term. So now that I've got that sorted, what I do is I then start to simplify it and write it in a much more general manner. So my binomial coefficient is still going to be 7r. I've then got the negative 1 to the r times, and I'm going to combine my x's. So I've got x to the 7 minus r times x to the minus r, which is going to be x to the 7 minus 2r. So there we go, that's my general term. All it depends upon is r. Now I want the coefficient of x to the power of 5. So what that means is my power here of x has to equal 5. So I can say, fine, I know then that 7 minus 2r has to equal 5. And for this to work, r has to equal 1. So what I now do is I can substitute r equal to 1 in, but all I'm after is the coefficient. So I can focus on this part here. So if I focus on that, I've then got my binomial coefficient of 7, 1, and that's then going to be times by negative 1 to the power of 1. The 7, 1 gives me a coefficient of 7, and negative 1 to the power of 1 is negative 1. So my coefficient of that term is then going to be negative 7. So there you go, the coefficient of the x to the 5 term in that expansion would be negative 7. Again, we've just done the same steps we talked about before. Get a generalised version of the term, figure out how to get there. So we wanted x to the 5, equate the power, find my r, plug it back in. The next question then wanted me to find the term independent of y in the expansion of y minus 3 over y to the power of 6. Now again, this has to be done in the same sort of format as before. So we've got our x plus y to the power of n. We have to write down the general expansion of that. So how's the general term going to look? And then figure out the conditions for it to be independent of y. So for this one, I know the x would be this y term here. And the plus y would actually take into account the negative, so the y part would be minus 3 over y. Now, a key point here, we've done everything in terms of x up till now. You'll have noticed in the textbook you can use any variable you want, so this is just to expose you to that. It doesn't always have to be x. We're not back in S1, 2, 3 or 4. We don't like the letter x in terms of it being the only one we use within algebra. Yeah, we can expand and use any single variable we want. So then I can say, right, so my general expansion is going to be nr, my x to the power of n, which in this case is y. So it's going to be y to the power of n minus r. That's then going to be multiplied by my second term, which in this case is minus 3 over y, and that's going to be to the power of r. What I can then do is simplify this bit here, taking into account the fact I know what n is, because I know from the expansion that n is equal to 6, see what I get, and then figure out my condition for r. So what that's then going to be is 6r y to the power of 6 minus r times, well, if I look at this term here all on its own, the negative 3 over y, what I'm going to do is write that as negative 3y to the minus 1. And I know that that's then all going to be to the power of r. So that's going to be negative 3 to the power of r times y to the power, it's negative 1 times r, of negative r. So this here is then going to be times negative 3 to the power of r times y to the negative r. So at this stage, group the coefficients together, group your variables together, see how it comes out from there. So I'm going to have my 6r, my binomial coefficient, times the negative 3 to the power of r. It's then going to be times my y's together, so it's y to the 6 minus r times y to the minus r. Add them together, and I get y to the power of 6 minus 2r. So there we go, we've got a generalised term in terms of r. Now we just need to figure out the condition on r that we want. Now we want the term independent of y, so in that case we want y to the power of 0. And for that to be the case, 6 minus 2r, our power, has to equal 0. For that to be the case, r has to equal 3. So now that I know that, I can take the r equal to 3, plug it back into the coefficient part here, and then figure out what I'd get. I don't need to worry about the y because that's going to disappear. It's going to be independent of y, that is not going to be there. So what I need to look at is then 6, 3 times negative 3 to the power of 3. So 6, 3 times negative 3 to the power of 3. So what that's going to give me is 20, binomial coefficient part, times negative 3 cubed, which is negative 27. Multiply the two of them together and I get negative 540. So the term independent of y in that expansion, if I were to do it, I'd find one term that was minus 540 without any reliance on the y variable itself. Working these through is actually fairly straightforward. It's not a difficult process, it's all about the steps. Get it written in a general format where you're relying on r, and then look at the condition you have to apply to r in order to be able to solve it. So if it's independent, the power is 0. If you've got a set power that you need to look at equating the power in terms of r to that power and what condition do you have to apply to r for it to work out. Then work it through and find out any coefficients that you need to at the end. Fairly straightforward process, you just have to bear in mind all the steps and be able to work it through.